All right, we're going to take a look at question probably 3, 4, and 5 in this video. Triangles TUV and XYZ are shown below. The triangles are congruent. So because it's congruent, we know that the sides match and the angles match. TU is congruent to XY because there is a reflection that carries triangle TUV to triangle XYZ. Well, I wouldn't say that there's a reflection. Let's see. T matches to X, so that's okay. It says U matches to Y. So if there was a reflection here, this U would actually match to Z. So it can't be choice A. Let's see. TU is congruent to XZ because of that reflection. And that does match. See? Here's our TU line. Here's our XZ line. If I were to fold my paper right here, this line would map over to be on top of this line. So I'm just going to put a check because I'm pretty sure that's the right one, but let's check. TV, this line, matches with XY because of a translation. Well, if it's a translation, it's like I'm cutting this out and just moving it this way. So the orientation stays the same. So it wouldn't be that one. TV, this one again, matches to YZ, this one here, because of a translation. And again, that would not be the case. It would have to be a rotation where it turns. So that's not the choice either. So we're going to be left with choice B. TU is congruent to XY because there's a reflection that carries the triangles onto each other. Here's question number 4. Finley has created a triangle HJK through a series of transformations applied to DEF. The transformations she used are listed below. So there was a vertical line and DEF was rotated on that line. Or I'm sorry, reflected. So it would be something like that. And then DEF rotated 30 degrees upon point D. And it doesn't tell you which angle, which way it did. So I'm going to go like this to kind of have it look like. It's not going to be perfect. But just kind of picture this turning 30 degrees. I did it clockwise. Are these congruent? No. They're not congruent because the rotation changes the clockwise order of the angles. That has nothing to do with rotation. Rotation maintains congruence. So we know it can't be choice A. No, because the reflection changes clockwise the order of the angles. Again, the order of the angles have nothing to do with congruence. And again, reflection maintains the congruency. So it's not choice B. Yes, because transformations taken are each rigid motions, which preserve angle measure and segment length. This is yes. This is true, but let's double check with the D. Yes, because the transformation taken alter the angle and segments precisely to match their corresponding parts. This is incorrect. This would be if it was similarity, and then in that case, it would be for dilations. But this question relates to congruence. So that's how we know. It's asking us about congruence. So that's how we know that it's the rigid motion that has that happen. We are back for number 5. All right, let's take a look at number 5. In the diagrams below, ABC is congruent to XYZ. So A is congruent to X. I'll just do that to help me out. Which statements identify the corresponding parts? So we know that AB, I'm going to put a 1, matches XY. So I'm going to put a 1. BC, I'll put a 2, matches YZ. So I'm going to put a 2. And then clearly CA and XZ match. So let's see how it works here. AB is congruent to XY. So that's true. I'm going to just check the sides first. BC is congruent to YZ. That's true. AB is congruent, AB has 1 line, is congruent to YZ, which has 2 lines, so that's not true. BC is 2 lines, is congruent to XY, which has 1 line. So now we know it's going to be between A and B. All right, now it says angle C matches to angle Y. So angle C is between the 2 and 3 lines. Angle Y is between the 1 and 2 lines. So I'm going to say no, but let's just double check. Angle A, which we highlighted yellow, is congruent to angle X, which is true. So that's how we know it's choice B.